During our research, it seems that the engine is the heart of BMW vehicles. We investigated all of the manufacturing and production processes used to make them. The questions that are answered in this report include: what type of material is used to make the different components of the engine, and what material properties make BMW engines perform to last and function for many years. The latest engine blocks, pistons, and crankshafts will be evaluated to understand the multiple manufacturing and production processes used to make them. The manufacturing of the engine block is done using sand casting, although die casting can be used as well. Die casting is more cost-effective, although the dies wear out easily due to high temperatures of molten metals. The casted engine block is machined to get the surface finish and coolant passages. In the sand casting process, the engine block casting is green sand mold casting. The term green denotes the presence of moisture in the sand mold. The combination of silica sand, clay, and water are poured into half of the aluminum block pattern with wood or metal frame. The mold is then compacted by applying pressure or vibration on the metal frame. This process is repeated for the other half of the mold. Then both halves of the mold are removed from the pattern. The solidification process controls most of the properties of casting. Most of the casting defects occur during solidification. It occurs in two steps, which include nucleation and crystal growth. In the nucleation stage, solid particles are formed within the liquid which have lower internal energy than the surrounding liquid. They go below the freezing temperature because of the extra energy required. It gets heated up to form crystal structure, creating the crystal growth stage. BMW crankshafts are typically processed through forging. Metal billets are heated at temperatures ranging from 1950 to 2250 degrees Fahrenheit. The corners are then flattened, pressed and pounded into shape while the surface gets descaled. Then the heated billet is repeatedly hit into place as it gets pressed down between pairs of dies using high loads of pressure. These plain dies are structured into any desired shape. Afterwards, the workpieces are clipped off axis metal and transported to a twister. The twister aligns 5 strokes relative to one another by pressing the crankshaft from the top and bottom. The number 1 and 2 main journals are reheated and twisted 90 degrees, while the rest of the rod journals are moved to a perpendicular plane. The dimensions of the shaft are tested and documented through a coordinate measuring machine. Forged crankshafts have an advantage over other forms of manufacturing processes because they lead to less fracture. They have continuous grain flow, a reduced chance of voids, and better fatigue resistance. The raw material used in the manufacturing processing of a piston is an aluminum rod. A rotary saw slices the rod into a specific size, which depends on the dimension of the desired piston. The process is called punch pressing and dyeing. The punch exerts 2,000 tons of pressure on the heated slug and shapes it into an initial form of the piston. After the parts are cooled down, they experience a machining process that shapes the piston crown by the CNC lathe. The process also corrects the shape for machines that handle the parts later. The small holes on the pistons are made by boring processing, which are operated by the CNC lathe. After the boring process is over, another CNC lathe cuts 3 grooves for compression rings and an oil control ring. A wrist pin is then produced by a drilling machine. A milling machine is then used to reduce the piston weight as well as correct the shape to make the piston as accurate as possible. The final process is the removal process that removes all lubricants and oils.